Hey again, it's Jeff, and I want to talk about a few more things regarding 3D modeling, some advanced topics today. You've kind of got the basics down at this point, so I want to talk more about construction geometry, which is super handy, but the sort of thing you get into as you move beyond X, Y, Z. You want to draw features or sketches in other locations in your models. And also talk a little bit more about dimensions and constraints. So let's start there and let's see where we go. So why don't we start with construction geometry. Now, I'm going to do a couple of random examples here. Just sort of imagine that these are scenarios that you're trying to handle in your 3D modeling. These might not necessarily be the best examples or the most realistic examples, but they'll give you an idea how to use the tools. So let's create a cylinder that will help us with our example here. So on my screen here, I'm just making a cylinder really quickly. Now let's say that you wanted to create a sketch on the side of this cylinder. Now, as you know, you can create a sketch on any flat surface, so you could do a sketch on the top. But you're not going to be able to create a new sketch on the side of the cylinder because it's not flat. So in that case, really what you need is a plane, a construction plane that you can draw on. Now there's a couple of ways to do that. If we go up to the construct menu, we've got the option to do an offset plane, which we could use. And then there's also a special case here called a tangent plane. Let's start with the offset plane. Now this allows you to create a plane that you're going to draw on that is offset from an already existing plane. So for example, I could choose this plane right here, and that gives me the option to create a new plane that is parallel to that initial plane but with an offset. So I'm dragging the arrow here out, let's say 20 millimeters, clicking OK, and now I've got this new plane that's spaced out, kind of in the middle of nowhere, but now I can create a new sketch on that plane. So for example, if I was trying to create a cutout through the cylinder, I could create that 2D sketch and then extrude it through the cylinder to give me that effect. Now let's undo back a little bit, and instead of doing that as an offset plane, let's take a look back in the construction menu here. We've got this other option here called tangent plane, and if we read the pop-up tools for this, pop-up tips rather, it says creates a construction plane that is tangent to a cylindrical or conical face. So that sounds more specific to what we're trying to do here. So you can create a tangent plane by selecting that option and then clicking on the outside perimeter of a cylinder. It'll create a plane tangent to that cylinder, and then you can adjust the location of that tangent plane. So again, you could create that and then go ahead and draw your 2D profile for your extrude operation or whatever other features you've got in mind. Now, just maybe a note on the sort of practical application of this. In this particular example, you could accomplish the same thing by just creating a sketch on one of the base planes. If I choose, let's see, I guess in this case I was basing it off of the XZ plane. If I do that same rectangular sketch on this plane, I can still extrude that. If I do an extrude operation with that sketch selected, I can change the direction drop down here to two-side or symmetric, and then when I extrude, I can go outward from that plane. So in this particular case, I could have accomplished it without the offset plane, but there's plenty of cases where you might want to create a 2D sketch in space, in a location where you don't have an existing feature on your model that you can draw on. So keep that in mind as a tool that you can use. Okay, here's another quick example using offset planes and other construction geometry. If you take a look at my screen, I've got a chess piece. I just did a really quick model here. You can see that I drew sort of a quarter or cross-section profile of a chess piece, and the left-hand edge is the z-axis. And then I just did a 360-degree revolution around that axis to create this three-dimensional shape. Now, if you've ever played chess, you may have noticed the bishop piece has like a slot cut in the top part that I think symbolizes the mitre of like a church official or something like that. And creating that sort of angled slot with an extrusion you might want to do a feature like that using an angled plane. So the way that you could do that, I have not yet come across a way to do this in one step, so there's a two-step process for setting up the construction geometry here. We will do a plane at an angle, and we'll set the angle on this axis here. So this is, I'm not sure if that's the X or Y axis, but one of the two. And then I'm going to take the angle set and drag it around to 45 degrees. So now we've got this angled plane. Now we can create an offset plane off of that angled plane that we just created. And I'm going to drag it up so that when I look at it from the side, this plane completely clears the piece. So if we were to extend this plane in all directions, it would not intersect the model. I can do a sketch on top of that new plane that I just drew. In this case, I'm going to draw a narrow slot that's going to intersect with the chess piece, like this. Oops. Like that. Finish the sketch, and then I can choose the extrude operation to bring that down and intersect with the chess piece. So from here you could go and revise the sketch and move that up or down. You could revise the placement of the angled plane if you wanted to change the angle. But this is one of those cases where you know, the operation you're trying to accomplish might require a sketch existing on a plane that doesn't exist anywhere else in your model. So it's up to you to create the construction geometry in order to accomplish that. Okay, so in this next example, we're going to talk about dimensions and constraints and the implications they have for revising parts. So dimensions are used to set a measurement between two features. So like a line or a circle or a rectangle, whatever, being a certain dimension from an edge or an axis or a point. So a measurement, basically, is what a dimension is for. And then a constraint sets a relative relationship between two things. So a point could be coincident with another point, two lines could be parallel, lines could be perpendicular, a line could be tangent to a circle, these sorts of relationships. So let's take a look at those. In this example, I'm going to create, well, I've got an empty component here. I'm going to create a new sketch, do it on the XY plane here, and I'm just going to make a rectangle. And this is going to represent sort of like the base of a part that's going to have some bolt holes in it. So let me extrude this up to a thickness of 5 millimeters. And let's do another sketch on the top surface here, and I'm going to create that bolt pattern. Now, I'm going to do it off to the side first so we can see it, and then we'll move it into place. Now, if you've got a rectangular pattern of 4 bolts, an easy way to do that is to use a rectangle. So you draw a rectangle, and then you locate the circles that will become the bolt holes at the corners, right? So it allows you to quickly draw a pattern of circles representing the bolt pattern. So we'll go to Sketch, Rectangle. I'm going to use a center rectangle for reasons that may become obvious a little bit later. I'm going to draw it off to the side, and I'm not snapping it to any geometry like the origin or anything like that, because I don't want any constraint relationships to sort of be put in by default by the program. I want to control all of that, and we'll talk through it. So I've got my rectangle that represents the bolt pattern, and I'm going to add circles at the points, 5 millimeter circles, at the points of the rectangle that will be our bolt holes. So I'm using some hotkeys here. You're probably learning some of those by now. Now there's one more thing. The rectangle here, if I go out to extrude these bolt holes, the rectangle is going to be kind of in the way because it intersects with the circles. So when I select the circles, parts will be cut by the rectangle, and I have to multi-select a bunch of stuff. So if you double-click to select that rectangle, you can use the construction toggle over here in the sketch palette to set that as construction geometry. And that will still work as a reference geometry, but it won't get in the way of like extrude or revolve or any of those kinds of operations. I'm going to drag this over and put it roughly in the middle of my base plate here, not being too careful about it. Just going to drop it down there and hit Finish Sketch. Oh, actually, one more thing. Let me set some dimensions on this rectangle first. That's just going to define how big the bolt pattern is, just because I think it might, if I don't do that, it might get in the way later. So I don't really care what the dimensions are. I'm just going to set them over here so that they're fixed and not going to change around. I'll drag this over. Drop it down kind of in the middle of my mounting plate and hit Finish Sketch. And now I will extrude those bolt holes. Notice that I can't click on the rectangle because it's construction geometry. It gets it out of the way. Very nice. Okay, and then we'll do -5 millimeters so the holes go all the way through. Okay, so I've got my bolt pattern here. Now, what happens if I change the size of that original mounting flange? If I make this bigger, right? I didn't set dimensions before, so let me throw a couple of dimensions on here now. It's about 80 by 90. So let's make it bigger. Let's make it 150 by 200. And we'll hit Finish Sketch, and that change will cascade through. So you can see our mounting flange has changed size, but the bolt pattern has stayed in the same place. Now maybe that's what you wanted, but if you expected it to be located a certain distance from an edge or in the center, when you resize the part, the holes aren't going to move if you don't have dimensions to locate the holes where they're supposed to be, or constraints to set the relative position to other features in your design. So let's fix that. We'll go back to the sketch where we created the bolt pattern, and let's set this to a particular location. Let's say, so all 4 circles are set relative to each other because they're referenced in that original rectangle that we made, but we can use the dimension tool to say that this circle is a certain distance from this edge, we'll say 20 millimeters, and the circle is also a certain distance from this top edge. Move that over here, we'll say that's also 20 millimeters. And we'll hit Finish Sketch. And now this bolt pattern is located precisely 20 millimeters from the left side and the top side. And what that means is if we go back and change the size of that flange again, the overall size of the part, let's make this 120 by 120. Oops, sorry, I messed that up. Wow. Undo. Let's try that again. Make this 120. Make that 120. I hit Finish Sketch. The bolt pattern is still fixed in its position in the upper left-hand corner, even though the part resized. But what if we wanted it to be in the center of the part? So how would we do that? Well, let's go back into the sketch, and I'm going to remove those dimensions that we just set. So once again, this bolt pattern is sort of unconstrained. Okay. And I'm going to add some more construction geometry that's going to allow me to put it in the center. So we've used this technique before. I'm going to draw a line from the center or the midpoint of the top line, and another line from the midpoint of the right side, drag that across. And where these two intersect is a point in the center of the part. So let me choose the first line. I'll hit X to turn it into construction geometry. Second line, you can use the toggle over here or the shortcut X. And I want to locate a point, so it's in the sketch features here. Choose point and locate that here where the two lines intersect. Okay. Now I can use a constraint to say, I'll use a coincident constraint and say the midpoint or the center point of my center rectangle that describes the bolt pattern is coincident with that point that I drew at the intersection of those two lines. Okay. Now I'll hit Finish Sketch, and you can see that the bolt pattern is now locked to the center of this part. If I go and I resize the original flange, I say this is now 250 millimeters on this side and 250 millimeters on this side. I hit Finish Sketch. You can see the bolt pattern relocates itself to the midpoint because of the constraints that I put on that bolt pattern. I locked it to a pair of lines that intersect at the midpoints of the two sides. So even though I resize the sides, those lines stay at the midpoints of those sides, and the bolt pattern stays at the intersection of those 2 points. So when should you use dimensions or measurements, and when should you use constraints? Well, I've seen videos online and seen tutorials that say that you should use constraints whenever possible because they are flexible, they are relative. I think that that's too broad of a statement. I think you should use dimensions where you have fixed measurements that are unchanging. For example, you're designing a part that bolts to another part, and the bolt pattern is determined by that part that already exists. You can't modify those dimensions or your parts won't match up. So in that case, it makes sense to use dimensions. But if you are locating geometry or parts of your design relative to other parts in your design and you want those relationships to stay the same, for example, you want something to be located always in the center of a sketch, it makes sense to use a constraint. So just think about what you're trying to accomplish and where the location of a given feature is relative to other parts of your design, and use either dimensions or constraints as you see as most appropriate. Okay, here's another quick example or practice for you, and it has to do with features in your design and working through them methodically to make revision easier for you later. Now, we're all guilty of designing a part really quickly, sketching it up, printing it when you need something in a hurry. And in situations like that, a lot of rules can be bent or broken. But if you're going through the effort of designing a technical part, and especially if you think it's going to take a couple of revisions, I highly recommend breaking it down so you have one major feature per sketch. And that makes a really neat organization in the timeline of sketch and then operation on that sketch, another sketch, operation on that sketch, alternating down the line like that, so it's easy to find features and modify them when you need to when you're revising. I'm just going to make up an example here, but take a look at my screen. As always, good practice, we'll create a new component and then a sketch. In this case, we're just going to do something like a rectangular base plate. Now, I'm going to show you what not to do. Let's say you were creating a bolt pattern, which is something I do a lot. So we'll create a rectangle like we've done in the past, make it construction geometry, put circles on the corners. And let's say that we want to create a pattern on the outside that's going to give us clearance for where other parts are going to be near it in the overall design. So I'm going to make some arcs here, and I'm going to cut away some of the material. And let's see. Now I'm also being extra lazy here, and I'm not carefully dimensioning things. I'm basically doing everything wrong here. But for the sake of an example, it's fine. Let's do another one down here. These probably aren't even going to be symmetrical. Hopefully, you guys watching this example later on, you're not going to get too upset about that. Okay, so I've got all of these features. I hit Finish Sketch. And then I go in and I extrude, and in this case, with one extrude operation, because I started with that base sketch, I've got a part shaped like this. And maybe that's what I'm going for. So the thing is, and this isn't too terrible of an example, but if I need to go and change some of those features, I could go back in and I determine that this arc is not the right radius and I need to make it something else like that or whatever. By the time I go back in and add all of these dimensions, this original sketch is getting really cluttered. Okay, organizationally, it'd be a lot better. I'm just going to undo a few times here. If I'm going to go even more extreme. I'm going to start with just this original sketch. I'm going to extrude it. I'm going to do a new sketch on top of that and do bolt pattern. Let's find the midpoints here. Make this construction geometry. Create my bolt holes here. Exit back out of the sketch. Extrude these. And then do another sketch down here and add those arcs back in. can go ahead and okay, so now I've got the same part, but each of the major features in this part, the main plate itself, then the bolt holes, and the cutouts for clearance, all of those are now arranged in the timeline very neatly, where I've got the sketch for the feature and then the operation to bring that into 3 dimensions, the next feature sketch, and then the operation, and then the next feature sketch and that operation. Organizationally, it makes it easy to find things, but when you get into more and more complicated parts, like I've got parts that have 50 features. They've been developed and revised over time, and organization becomes really important. So keep these things in mind and try to train yourself with habits now, even when on simple parts they may seem unnecessary or over the top. In the long run, they're going to build good habits, and it's going to save you a lot of hassle later on. We all revise parts, we all iterate parts, especially as we get into more complicated designs where we have an idea of what we're doing, but you don't know how the features are really going to interact, and there's a lot of measurements. We have to revise, and setting up good habits now is going to save you a lot of time, effort, hassle. It's going to speed things up.